The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome everyone to today's webinar. My name is Rishab. I am a marketing associate at Struxoft Solutions, part of Greater Group, and I will be your host today. Joining me is Aparna, our senior implementation specialist, who will be taking us through creating framing for stairs using MWF. For those of us who are new today, our STAR solution MWF, which stands for Metal Wood Framer, is a Revit-based BIM framing solution that automates the creation of walls, floors, ceilings, and trusses in light gauge steel and also in wood. Before we begin, please note that we will be taking live questions at the end of the webinar. If you had a question, you can raise your hand in the GoToWebinar dashboard so I can get to you. Also, please make sure that your mic is working correctly. You can also ask questions during the webinar by typing them into the questions tab of the webinar dashboard. And of course, you can do the same at the end of this webinar. So that's it from me for now. Hope you enjoy the webinar. And Aparna, the floor is yours.
Hi, everyone. Like Rashid mentioned, my name is Aparna Bhatia, and I'm a senior implementation specialist at Struxoft Solutions. Today, we're going to try to tackle framing stairs with MWF. So we're going to quickly learn how to draw stairs in Revit. We're going to convert each step into a floor, and then, or not convert, like create a floor for each step. And then we're going to learn to create stair framing per step. And then we're going to add sheathing on the stairs as well. All right, so let's get started. So here I have a layout. It's a level 1 layout. I've created 2 callouts, one for the south stairs and one for the north stairs. So I'm just going to go inside that callout over here. So that's my callout for the south stairs. So in here, the architects have already drawn their stairs, and they've drawn their stairs as multi-story stairs. So I can either choose to copy the architect's stairs and then use that as a guide. But since I'm going to show you how to draw the stairs, I will kind of go through that process on here. Okay. So we'll recreate the stairs that the architects have created. So here, I've copied in the architect's multi-story stairs just so I can grab some data from them. Over here, we have an assembled steel pan stairs. If I hit the edit stairs button, I can actually tell what's the width of the run here. I can also tell the gap between the steps here. If I wanted to mimic that, I could mimic that. And then I could also, I can kind of get a gist of the riser height and the tread depth. So the riser height is the step you're going to rise up. So you're taking the step up. And then the tread depth is basically what you're stepping on. So the step depth itself, okay? So we just need that little bit of information. And we also need to know what levels the stair is starting at and going to. So our desired stair height is 12 feet. So that's kind of what we're going to try to create. So let's do a quick, let's start drawing our stairs, and then we'll do a quick overview of how to draw stairs. So we'll click on the architectural tab here. Under the architecture tab, you have the option to draw stairs. So we're going to quickly draw a stair here. For this stair, it automatically detects that we need 21 riser steps. And that is because we have a 12-foot height for our stair, or like our desired floor-to-floor height for the stair. So we already have that 12-foot height as a guide. And then the other thing we want to do is the other way it determines that we need 21 is if I go to the edit type for the stairs, over here, it says our maximum riser height is 7 inches. So this data you can kind of find out from the code, depending on where you're building your project. So maybe if you're doing it, for me, I'm in Ontario. So in Canada, for us, our maximum riser height is 7 inches. So that's what's put in here. And then our minimum tread depth, so what we're going to step on, is 11 inches. This kind of helps make it a little more comfortable for the general public to walk on these stairs. If you look at older buildings, the maximum riser height might actually be a little higher. So it might actually be 8 inches or something like that, or 10 inches. That's why like the steps are so deep for us, and or they're too high for us to climb, basically. So they modified the code over time, right? So for us right now, it is 7 inches. And over here, it says a minimum run width. So this is, again, by code. This is the width of your stairs that you're walking up on. It has to be a minimum of 3 feet so people can actually fit on the stairs. So if someone's going up and coming down at the same time, they both have space, okay? Or if multiple people are walking up the stairs together, they still have space to walk up, okay? Over here, we have our option for the run type. The run type basically tells you what's the profile or the shape of the step that you're going to be stepping on. So it's kind of like the section view of your step. So if I go here, you can specify your materials for your step. Right now, we're just drawing the stair as a guide so we can draw our floor on it. So our tread material here, you can specify it if you like. For us, we're just gonna leave it as blank. We don't really care, we're just using it as a guide. The tread thickness is what you're stepping on. And then the nosing length is the little extra extension piece here. So whenever you look at steps, say pretend this is going up and then this is the tread, you will typically have like a little piece that comes out here. That's your nosing, that's your 1-inch nosing. So here you're choosing the profile for your nosing, and then you're choosing how you want to apply it. Right now we have applied it only at the front, but if it's a feature stair, you might want to apply it front, left, and right. But for now, we're just going to do front only. We're just going up the stairs and around, right? So we're just going to leave it as front only. You can choose if you want to add a riser. In our case, we're creating a floating stair, so we don't need a riser. If you wanted to create a slanted riser, you could create one of those as well. Okay, this basically means the part that that's created when you're stepping up. So this little support here, do you want it to just go straight up or do you want it to be slanted? Okay. For right now, we're not using either because it's floating stairs. So we're just leaving that as nothing. So this is just your profile for your steps. Once you choose that, you can choose the function of your stairs, and then you have a few support options. So you can choose a right support, like if it's exposed stair, like there's no walls on either side, I would probably use a stringer. But in our case, it's like a floating stair, so we can technically use a carriage support. I'm going to use, instead of one, I'm going to use multiple carriage supports. So I'll use 2 carriage supports for our stairs. And I'll show you what they look like in a little second once we start drawing them. And you'll notice that they will evenly distribute themselves. So we have no left or right support. We only have the support at the at 2/3 and 1/3 of the step, okay? Or of the width of the step. So that's that. And now that we have specified how our stairs are going to be drawn, we are now going to draw our stairs. So you can specify how you want to draw them. For me, I'm just going to use the center of the run as my guide. If you wanted to actually trace over the architectural stairs, you can choose the left or right as your guide. It's up to you, and then move it over. It's totally your choice. Okay, so I'm just going to use this center as a guide, and we're going to just try to draw our stairs. So since our minimum run width is 3 feet, and we just noticed that when we looked at those stairs, it was 4 feet. Over here where it says actual run width, I'm going to change that to 4 feet. And then over here, I can just start drawing my stair. So I'm just going to start drawing from the middle. Let's create 11 risers. And then as we can see here, it skips a step and then starts the next run. And it's going up from here and continuing on to the second floor here. So this is level 1. That's what ends at level 2. So we're going to start and do that. And over here, we're going to start drawing the middle of the next one. So this way, these two are aligned and the cut of the opening is consistent for both. Okay. So now the space in the middle, we can either dimension this over here from the architects. So from here to here, the dimension is 2 foot 6/8. I can just copy that dimension and then hit delete. And then over here, I can try to match that dimension. So I can go here and paste it, Control V. And there you go. It kind of creates that same gap that these guys have. We're going to just ensure that our stair width is 4 feet. By code, we need our landing width also to be a minimum of 4 feet because it has to match whatever our width of our stairs is. So we're going to leave it at that. It seems to match right now, and it's all looking great. So once we finish this, our stairs are complete. I'll also talk a little bit about the different types of stairs we have. So I'm just going to go to level 1 for a second and doodle over here, just so I could show you the different types of stairs we have. So here you'll see that we can draw a straight run, like how we just did for this guy. You can draw a spiral full step stair. So if I was to draw this, you can actually draw something like that. And that's a full step stair. It doesn't need a landing. It just keeps continuing on until it completes all the steps. Over here, we're going to draw, you specify the center and the ends of a spiral. So center, I want the stairs to go from here to here. And that's how you do that. And over here, the reason it's saying 21 plus 22, and then here it says 21 plus 42, is because we've already drawn one stair in this sketch. We can't have multiples. So it's like, what are you trying to do, basically? Okay. So I'm just showing you a few of them here, but that's our actual stair that we're going to use. And then you'll notice that we have an L-shaped winder and a U-shaped winder. So the winder stairs, they're typically used for right there you go. So the winder stairs are typically used for residential buildings, right? Because basically what the difference between a regular full step stair and a winder stair is that you see how these ones are just parallel, and then just to prepare for the curve that's coming up or the turn that's coming up, it's going to start sloping all of our steps and creating something like these triangular or trapezoidal steps, right? So basically, that's the difference between a winder versus a regular straight stair. Whereas if I drew a straight stair, it would draw a landing. And over here, there you go. So now if I draw a winder U-shaped stair, it's doing the same thing. It's preparing for the turn, and at the turn, it's creating these diagonal or triangular steps. And basically, the reason this is mostly used for residential is because for most commercial places by code, you need a landing because you can't expect people to just keep running up the stairs as they go along. You need a rest place. So typically the rest place is at, I think it's an 8 foot, 6 foot or 8 foot minimum requirement. So if once the traveled distance exceeds, or the traveled distance exceeds, I think 14 steps or 13 steps, you have to place a landing, basically. So for commercial places, this is what's the requirement. So yeah, that's basically it. That's why we have a landing there. Those are your different types of stairs that you can create. So I'm just using this as a guide for myself. And over here, you'll see these little guys here. That's the carriage support that we chose for our stairs. So they're evenly distributed here. If I was to change that number from 2 to 3, it will add an extra 1, and it will keep it evenly distributed all the way through. Okay, so we can just reduce it back down to 2 or 1. It's up to you. I'll leave it at 2 for now. Okay, so this is basically how the steps are being supported. Technically, I would probably put this at 3 so that it can actually be under the joists, but we can make that decision later. We can change that support system later. And we're mostly supporting these stairs with our framing. Okay, so we're going to do the checkbox. That's done. Now that I've created these stairs over here, I don't really care about the railings, so I'm gonna delete the railings. They get automatically created when you create stairs. Over here, we have a stair path. We don't really need to see it. We can probably get rid of that as well, but it's a good guide for you to know which way is up, basically. So here you can see that zigzag that tells you that, hey, that's above. If you don't really care about the stairs above, you can turn that off. But I need that as a guide, reference guide on this level, in this plan view. So I'm gonna just leave it that way, okay? So now what I'm gonna do is I'm going to go and create a section over here. So I'm gonna create a quick section over here, just so that when we're working with the stairs, we can see the elevations for all of our floors that we're gonna create now. Okay, so for the steps here, the first thing we're gonna do is create a floor, because we want the floor to basically be there for us to be able to frame it, right? So we're gonna go to the architecture tab or structure tab, either or is fine. And we're gonna use for me, I already have a floor pre-created. So I have a 1/5/8 stair slab created. You can create whatever size floor that you need to based on your framing. So for me, it's 1/5/8 inch stair slab. And I'm going to use pick lines to draw my step. Actually, instead of pick lines, let's use rectangular, okay? So here you can see that there's a little dash line like this. This is your nosing distance. So we know that our tread depth is supposed to be 11 inches, plus that 1 inch nosing makes it 12 inches. Minimum is 11, right? So when I draw this should be 1 foot, which is correct. So the nosing overlaps the step below. So that's why for the step above, you can see the nosing line here. So I'm going from the edge of the nosing to the edge of the step or the tread, basically, okay? So I'm just gonna draw that little piece there. And I'll just show you quickly what's the assembly of my floor here. So the actual total thickness is 2 1/8, and that is because it's 1/5/8 here, which is 162, or 1.62 inches. And then over here, we have 1/2 inch of plywood on top, okay? So that's basically the assembly of my slab. If I wanted to tag anything, I could put in some comments, type comments or type mark, to be able to tag it later in the future. But for now, this is all we're going to do, okay? So once we create that step, we're gonna hit, actually, I'm gonna just double click this. Yeah, okay. Once we create the step, this is what we're gonna do. We're gonna hit the checkbox. And then over here, I'm gonna quickly go inside the section view. So I'm gonna just shrink this down to this guy because we're only worried about the steps right now. That's the architectural model, so we can actually hide that in the view. We don't really care about it. I'm gonna make this fine and maybe make it a little more detailed. And if I wanted, I could make it shaded so I can see what I'm drawing. But for right now, I'm just gonna make it in line. Okay. So over here we have this step, and then we have our slab drawn here because it's at 0. We actually want it to be aligned to the top, and you'll see the stair profile. So the actual tread depth is from here to there, and then we are adding this nosing profile at the edge. So if you want, you can actually create your slab to just be the tread depth, but and then add the nosing profile as an additional piece later on. Or you could just, for me, I'm just going to do from this edge to that edge to be the same slab and no additional nosing pieces. And I'm just treating the tread of the full tread to be what it needs to be. Okay. So I'm just going to move this step from here to the top. So there you go. So my floor slab has now moved to the correct location. That line you're seeing is my sheathing. So that's the sheathing piece of my slab. And you'll notice that my slab's a little deeper. Maybe that's just the way we want it designed. So it's no problem. This might just be in a representation by the architect. Maybe we're drawing it the more accurate way, right? So this is just something you could figure out based on specifications, okay? So we're just going to draw it this way. And so now that we have that slab drawn, we're going to go to our level 1 here and find that slab there. And we're going to create a model group. Okay, we're going to group our floor and basically call it stair, step, slab. Oops, slab. All right, so we're going to hit OK. And now we have a model group. So now now that we have this model group, we can actually copy this up along all the steps. And we also have to create a floor for the landing. Okay, so now that we have this model group, we're going to copy it up all the steps. But I'm going to use a section to do that, just so that I can make sure that they are all going up and placed on the right spot, right? If I do it on plan, I have to keep remembering what the height was that it has to keep going up by. So I'm just going to do that here. So I'm just going to use the copy command here. And I will use this little edge here to basically place my slab for all the other ones. I will make sure that there's no constraint checked on, and I want multiples because I want to keep placing them for the levels above as well. So you just keep doing that. We'll really quickly just copy that all the way up. There, 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 and there. I can copy it up one more to be at the landing level, but we don't need a group there. So what I'm going to do is I'm going to copy, I'm going to go to the plan view that we had, because this one's going here, right? But now we want the group to be moved, like copied over that way. So what I'm going to do is I'm going to copy my this slab here over here. And then I'm going to go back to my section view and take a look at that slab. So that's where I drew my slab. And now I'm going to just move it up to its actual location. And now we'll follow through with the exact same thing we did here. We'll just copy the floors up. So we're going to take that step, go up, whoops, undo. Again, we'll continue the copy process. So click here, copy. I'm going to go back to that little piece there, 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 and there. And the last one is there. Typically, the stairs will not go all the way to the floor. It counts the step over up to the floor as an actual step. So it doesn't draw that step itself. Okay, it's just something to keep in mind. So now that we have all of our slabs drawn in, we're going to go to the plan view to try to draw our landing slab. Okay, so I'm going to go back to architecture, floor, and we're going to draw that landing slab. So I'm going to select the pick lines in this case, and I'm going to just pick the lines for the edges of the landing. So these ones I know where they're supposed to go. And for this guy, I know it's supposed to be here, because when you're going up, this is the nosing, right? So in this case, this is the nosing. But for here, the nosing is actually at that location, because you are actually the nosing for the landing, or the edge of the landing, is actually at that location, because this is the nosing going upwards, right? Because that's how the steps are working. So this is where we're going to draw it, and we're going to just connect the dots and make sure that this is a closed loop. So I'm going to make sure that this actually just gets connected here, and everything looks nice. Okay, so our span directions in this way, that's totally fine, and we'll just hit the checkbox. And now what we want to do is we want to make sure, you'll see that now when I select here, it's selecting the stairs. So if I hit tab, it ends up selecting the landing. So this is the height of the landing. So I'm going to go ahead and Control-C, copy that. I'm going to go back to that section, because our slab actually drew itself on level 1. We never specified a height. So now we're going to paste that height offset there and make sure that it's drawn in the right location. Seems like it is drawn in the correct location. We have the little gap underneath, which is perfect. So now that we have all of our slabs drawn in, let's go back to our south stairs. And over here, I'm just going to hide my stairs. So I'm going to go VV. I'm going to go to stairs and just turn them off for right now because I don't need to use them as a reference anymore. I've already drawn it. So here you'll notice that we can't see the stairs above, and that's because of our view range. Our view range right now says that from level 1, our cut plane is at 7 feet. If we set up our cut plane to be, I don't know, our height of our floor was 12, from floor to floor was 12 feet. So if you set it to 11 feet here, and we set this to 11 feet, foot 6, maybe, for example, we can hit OK. We'll be able to see most of the steps. We don't see the last one there. That's all. Okay. But basically, you can set this up however you like, and it's just this way. So we're just gonna, oops, no. We're basically gonna come here. Oh, don't flip the section. Go back. There you go. So we're gonna come here, select that one slab. Let's actually select all of this stuff and go to 3D. And actually, there you go. So we'll ignore the link in the background, the architectural link in the background, but we're just going to focus on this now. Okay, so for these stairs, I'm going to tab and select the floor. You can create your template however you like for your floor step slab. For me, I've already created one, so I'm going to use that one, but I will definitely show you what's inside the template once we create it. So let's go ahead and tab and select the floor from within the group. And then we're going to use the stair framing one that I created, and I'm going to say frame it now. Let's create. Okay. So here you'll notice that we don't have any of the joists created in here. So maybe I have to rotate this so that my joists can actually create in the middle. So we'll just go ahead to the top view here. And we're just going to rotate it by 90 degrees. And then we're going to regenerate the floor slab again. So we'll come here, regenerate. All right, there you go. So we have all of our floor slab elements created here. Our floor panel name is actually showing up this way because that's how it was originally. If I hit the space bar around 3 times, it will kind of show it in the right way that you want to see it. Just keep in mind you'll have to do that for these other slabs as well. Okay, so now that I've done this one single slab, I can go back to my 3D view. And what I'm going to do is I'm going to select the group that this was created for. I'm going to go to MWF, go to modular within the floor module, and then I'm going to say copy members on all identical groups. So we're going to go ahead and do that. So what this does is it will find every single stair step that is created with that group, and it will frame that step. So right now we have north stairs and we have south stairs, and they go up 4 levels. So if I use the exact same framing for the entire building for north and south stairs, I just have to create one template and make sure the group is copied everywhere in the correct location. And then I have to just copy members to all identical groups, and it will really quickly frame my entire project with the steps framing. So let's select all of these instances visible in view, and we're just going to quickly regenerate it. Give that a quick second. And while it does this, the next thing we're gonna go ahead and do is frame our landing. So give it a quick second. It's almost done. And there you go. So we just framed 21 steps in a few minutes. We're going to come here and quickly do this landing. with the same template. So let's go ahead and do that. So I'm going to go create. If you have different framing for the landing, you can go ahead and create a template for that on as well. So what I've done with this template is I've created a copy of the light gauge template and then just modified the families to be what I like them to be. Over here, since all the names are kind of weirdly rotated, I'm going to right click, select all instances visible in view, and I'm going to shift select the one that is actually correctly placed. And for the rest of them, I'm just going to hit the space bar on my keyboard 1 time, 2 times, and 3 times. So I have it reading correctly all the way up. And for that side, if I wanted to rotate it the other way, I could definitely do that as well. Okay, so that's basically how you rotate your slab. Now let's go take a look at what's inside the template. So I'm gonna select this widget over here for the landing, and let's go take a look at our properties for the template. Since your stairs kind of can be located and oriented in multiple different ways, the rotation, I prefer to rotate it with the widget, but if you knew exactly how your stairs are going to be located in the entire building, you could always set the position up to be correct and set your joist rotation to be accurate, correctly done as well. So here for the position, I've set the member reference to bottom, structural face bottom as well for alignment layer. I don't have any openings in here, so that doesn't really matter. For your stair, for your panel prefix, you can write stair. I can even change this to be an alternate name instead of, panel prefix. But this is just how we're going to leave it for now. So right now it says stair floor panel. If I just wanted to say stair 1, stair 2, I could just put it in the alternate name. Let's go take a look at our tracks. So for our tracks, we only have a single track, and then we are using the same family for both ends, start and end, and we're using the SSMA T162 T125-18. And then the rotation, I've set it to align to host. And then for the vertical position, I have set that to bottom. Okay, because I wanted to align to the bottom. So I'm gonna hit cancel for that, or okay, whatever you prefer. For the end joists, we did the same thing, single, and we changed the family to be 162 T125-33. That's what we're using for our end joists. And again, rotation is aligned to host and bottom. For our side tracks, we don't have any really for these steps, but we do have it for we might need to use it for the landing sometimes. So I have set it to be same as track. And then for your joists, you can choose your families for this as well. And you can basically, for us, we've only chosen sickle. If your spacing ever changes, you can just change your first joist and your regular spacing. Currently, the joist span angle is 270. That's the rotation that it's currently using. If you know the rotation, you can type that in here and save it as part of your template. If you don't, then you can just rotate the widget and it does something similar, basically. And over here for the size and the family and the type, we are using the 162 T125-33 for the joists, and we're not making any extensions, and we're not repeating any spacing. Okay, but if you wanted to adjust the spacing, you could do that over there and hit cancel. We don't have any extra joists. If you wanted to add them, you could definitely do that here. And then we did add sheathing at the top because we wanted to frame it out and have a clean sheathing or plywood sheathing on top. So here we've enabled sheathing at the top of the panel. We've chosen the layer 1 to be for the sheathing to be placed, which is this guy here. And the type is just default. I haven't changed anything there. And over here, the thickness, I have set it to 1/2 inch because that's the depth of that first layer there. And then I've only added like a 1/2 inch offset here so that it actually extends out of the floor if we are putting in any risers. But you could also use this extension to use it for your nosing. If you have that additional little extra piece that you're going to add in later, you can always use this as part of your extension tool so that you can cover that nosing piece with the sheathing as well. Okay, so I would have put this as 1 inch if I'm planning on doing it that way. Keep in mind, if you rotate your panel, your offsets for your sheathing need to be adjusted because now that's no longer the bottom of your panel. And yeah, basically that's it. If you do want to stagger your sheathing, which I don't think we need to do it here, maybe for the landing, you could definitely specify a stagger offset, but I haven't changed much from the default settings here. We have no cutbacks. We haven't specified any. We're not using any connectors. If you did want to, you could definitely add them in. For us right now, we're not using any. And if you wanted to add in like a riser at the bottom and you just wanted it to be a sheathing piece, you can definitely just add in a belly band sheathing for that purpose. I'm just going to double click and show you. Again, if you rotate your floor, just keep in mind this changes. So this is kind of like a little bit of trial and error. You can enable sheathing where you need it to be, and then you can specify your bottom offset and your top offset from the actual structural framing piece. And yeah, that's basically it for belly band sheathing. We have no fastener counts yet for this panel. I haven't done any edits, not used any manufacturers either. That's basically it. It was a very simple template. All I mainly did was change the families. All right, I think that's it for this week's webinar. If you guys have any questions, please feel free to ask.
All right, thank you for the demonstration, Aparna. As she said, we have some time to take any of your questions. So I see that we have a question from Combe. Just 1 second.
Hi. So basically, you were asking if there's any advice for framing a support stringer. Well, if you use the stairs reference, so let's go VV and let's go ahead and add in or show our stairs back. So if you use your stairs, like these ones, the ones we used as the reference, right? So if I use my, go ahead and click on my stairs, instead of actually drawing it with a carriage, how I just currently did, I can actually use a support stringer over here, and I can choose the size and shape of my stringer here. So if you ever wanted to track this change, you could definitely track that change. If you wanted to add a middle support later, you could add that in as well. But if I just change the type of stairs, I can grab data about my stringers in schedules as well. Does that help? It's McKee, is that right? Yeah, Colm McKee, right? Hopefully that answers your questions. Using Structsoft, using LGS material, I wanted to create. So we currently don't have that option, but if you wanted to create a stringer, I don't see a way to do that right now, unless you can maybe do it by cheating a little bit. You can create a sloped slab and have the stringers as your end joists. Maybe that would be a way you could create your stringers. Maybe for the landing, for sure, you could use that method. But by default, no, we don't really have a way with MWF to create a stringer. Any other questions? I see Theron has his hand up.
Yeah, I'm just gonna unmute Sharon. You're good to go.
Oh, hi, I just got my answer. Like they asked the question, the same question that I wanted to ask, so I got my answer in the previous question.
All right, perfect.
Okay.
Okay, thanks.
No problem. So Colm said that I've used a wall panel to create stringers previously, but it's a bit messy. But yeah, I agree. It would be really messy. But if you really wanted to create something on the edges like this, I would create it as a floor panel. That is the depth of the stringer. And then use your end joists or your rim joists. Your end tracks or as your stringer material or your family for your stringer. And then just make sure you didn't have any joists placed at all. So the spacing for your joist would be ridiculously high. So you'd only have the start and the end joists created and then your end tracks created. So yeah, that would be the way I would do it if you want to really frame it. But I would create a sloped floor in that location and then do it that way. Only thing is you won't really get these cuts automatically for if you use a floor slab, I would say. Wall slab, I don't really know if you could use a wall slab for this. Yes, you could, but yeah, you're right. It would be very messy. You're basically deleting everything except keeping just one item in there. Okay, cool. Any other questions?
All right, we're just going to wait a few more seconds to see if we have any more questions. And I'd just like to remind everybody that the recording of this presentation will be sent through email tomorrow. And also, if you would like to see the recording early, you can see that by the end of the day today on our social media channels. Also, please feel free to share the recording with any of your colleagues. So it looks like that's it. That's a wrap for today. So also, if you have any questions about this webinar, anytime after this webinar, please feel free to reach out to us, and our contact details will be provided along with the recording tomorrow. If you would like to have a one-on-one demonstration with one of our product experts, we will be happy to set that up as well. And we will now be ending the webinar. Thank you so much, Aparna, and thank you to everybody who joined us today. We hope you have a great day.
All right. Have a great day, guys. Bye.